Rasterization. So we have 3 points here, fresh out of the window to viewport mapping. And these points are now in pixel space. So what we need to do is to fill in, or what rasterization does is to fill in values for the rest of the pixels in the triangle that has these corners. Right now we're just going to look at the linear interpolation of colors, or the linear interpolation of the varying variables that get sent into the fragment shader, and we're going to figure out what the value will be for this particular variable in this case. So we'll start with looking at the points and their positions, just to draw up a little image of how this looks. So it doesn't really matter where the edges of the viewport are. We're somewhere inside the viewport. It doesn't matter where its edges are or exactly where our coordinate frame is, but let's start with the first point. Say we have a point here. So this point here is 8.3. Okay, the next one was 6, 7, meaning that we're going 2 back here, and so 2 back here, and and 4 up, so it's somewhere around here. So we have a point here which is 6, 7, and the final point was 14, 9, which means that it's 6 forward from the original point, so somewhere around here. So somewhere around here. It doesn't matter that much exactly how this is, so this was about 14.9. Might be a bit further to the right. But the main thing is that we're going to be drawing this triangle here, and the pixel we're looking at has a y value of 5, which is somewhere between 3 and 7. So our current scan line has y equals 5 here. So what we need to find is x left and x right. So x left and x right. So that's the first thing that we do. So we're going to do linear interpolations here. So we know now that we're going to be, to find x left, we're going to be interpolating between this point here, which is P1, and this point here, which is P2. And the values we'll be using for the interpolation is, to begin with, the x values of the points is what we're interpolating. So we can say x left equals the linear interpolation of 8 and 6, which are the x values that we're interpolating, and then the parameter that we're going to use we need to find by taking how far along we are, that is y minus the y value of P1, and then the entire length that we're going divided by the entire length that we're going, which is the y value here minus the y value here. So that parameter, you can just write it down here and say we have 5 minus 3 divided by 7 minus 3, which is 2 divided by 4, which is a half. Okay, so between 8 and 6, and our parameter is 1/2. That linear interpolation will be 1 minus 1/2 times 8 plus 1/2 times 6. It's basically their average, so x left will be 7. So we have an x left of 7 here. and we have x right, which equals the linear interpolation between the x values here of P1, sorry, the x value of P1, which is 8, and the x value of P3, which is 14 now. Then we have a parameter, and we need to find that parameter from the y value P1, the y value of P3 here, and how far along we are. So there we're going to have parameter here, which will be 5 minus 3 again, divided by 9 minus 3, which gives us 2 by 6, which is 1/3. So our parameter here will be 1/3. So we're 1/3 along the way from y equals 3 to y equals 9. So we're going to find the x value, which is 1/3 away from x equals 8 to x equals 14. So we're just taking the same part or ratio of how far along we are on x in the x direction, and applying in the y direction, and applying that to x. So this is 1 minus our parameter times 8 plus the parameter times 14. So x right in this case is 2/3 times 8, which gives us 4 plus 1 1/3, 5 1/3, plus 1/3 times 14, which gives us 4 2/3. So 5 1/3 plus 4 2/3 gives us 10. Okay, so we have an x left of 7, we have an x right of 10. So here we have 7, here we have 10, and then we can continue with this. So now we know what the edges are on the right side, except we need one more thing now. We need to use these same parameters to interpolate the colors as well. So let's look at the colors here. We're going to interpolate the color from P1 and the color from P2 in the same way as we interpolated the x value from P1 and the x value from P2. This is obviously supposed to be P3 here. So then we interpolate the color from P1 and the color from P3 in the same way as we interpolated the x values from P1 and P3. We have 0.2, 0.5, and 0.8. So we have these parameters here. So we can simply write this up here and say, should save this here. We have x left equals 7. We have x right equals 10. That's there. Now we can go and say we have b underscore color left, and that's the same linear interpolation except between the colors. So the color of P1 was 0.2, color of P2 was 0.5, and the parameter between y values of those was not 1/5, 1/2. Okay, which gives us 1/2 times 0.2 plus 1/2 times 0.5. This would be 1 minus here. So in between 0.2 and 0.5, we end up with 0.1 plus 0.25, so it's 0.35. 0.35, and we have the underscore color right, which is the linear interpolation between P1, which was 0.2, and the color of P3, which was 0.8, and we have the same parameter here, which is 1/3. So this gives us 1 minus 2/3 times 0.2 plus 1/3 times 0.8. So two-thirds times 0.2. Let's see if we can. So from 0.2 to 0.8, we have 6 points, and we're 1/3 along the way. So it'll be 0.234, 0.4 will be answer for this. Okay, so these colors obviously are pretty close, the color on the left and the color on the right, but we're still going to have to end up with a linear interpolation between them. So okay, now we have, let's just look at the image here. So we found the x value here for the end of the scan line, which is x left. We found the x value here for the other end of the scan line. So the scan line itself is scan line with y equals 5. We found the left value, and we've also found a color value for this left value. We found the right value along with a color value for the right value. Now we need to take a linear interpolation between these color values using the x that we're supposed to be calculating. So the algorithm will now basically do a for loop from x equals 7 to x equals 10, stepping in, doing the calculations in each step. But we're interested in pixel 9 and 5. So we've already used, we're in the scan line 5, now we're going to use the value 9. And we're going to say, okay, how far along are we from the left side to the right side if we're in 9? And we can see that it's 2/3 along, but we can do the same type of calculation here and say we have this parameter here, which is going to be 9, which is our current x, which we're calculating for, minus x left, which is 7, divided by x right minus x left. So the entire way, or how far along we are, divided by the entire way from left to right. This gives us 2/3. So that's our parameter at x. So we know what pixel we're going to fill. That's the pixel 9,5. We need this parameter to linearly interpolate the right color, so the correct color. So we're going to interpolate these colors, v color left and v color right, and we're going to say v color in 9,5 equals the linear interpolation between 0.35 and 0.4 using the parameter 2/3. That's how far along we are along the scan line. Earlier we were using how far along are we from the first scan line to the last scan line between the particular points. Now we're within the scan line, we're going the x direction. So here we calculate how far we are along the scan line. Here we use that ratio into the linear interpolation. So this will be 1 minus 2/3 times 0.35 plus 2/3 times 0.4. So that's 1/3 times 0.35. We can just do a calculator here. Let's say we have 0.35 divided by 3 plus 2 times 0.4 divided by 3, which equals, okay, 0.38333. So 0.383 is a good enough answer here. So, or actually, that's a good enough approximation, but what we're interested in is an actual answer to the question. So always make sure you read the question and then answer accordingly. So this is just one of the factors. We should say the color for the pixel 9.5 equals 0.383, 0.383, 0.383. So that's full color red, green, blue. But obviously it makes it simpler for us to have the grayscale. If we didn't have a grayscale that is the same value for red, green, and blue, we'd have to do this part here 3 times. Once for the red values, once for the green values, and once for the blue values. But all the rest, well, and the linear interpolations for the color in left and right, we'd have to do 3 times as well. That doesn't really add anything to the problem, it just adds to how much you have to write down. So here's our final answer.